Hi students, welcome to my channel Excellent Ideas in Education. Today we are going to solve this shear force and bending moment drawing for overhanging beam. Draw a shear force and bending moment diagram for overhanging beam with UV and UDL as shown in figure. You see this drawing, three forces is given B, C, D, one UDL load, one UVL load. First we will draw free body diagram of the given support. Second, use equilibrium condition to find RB and RD. You see here this RB and RD reaction we need to find. Third, we will calculate shear force calculation. Fourth, we will calculate bending moment calculation. Fifth, based on the shear force calculation, we will draw shear force drawing. Sixth, based on bending moment calculation, we will draw bending moment drawing. Now we will draw free body diagram. You see in this drawing is given is UDL load. So how you will convert point load in this case? UDL load is given as 15 kilonewton per meter. So distance given as 3 meter. What is the formula? UDL into distance. So UDL is 15, distance is 3, is 45 kilonewton. Now the point load is 45. So how we will take the distance in this case? So distance is B by 2. So B is 3. 3 divided by 2 is equal to 1.5. So distance is 1.5. Now draw the line. This distance is 3 meter. Now we will draw the point load here. So this distance is 1.5 meter. So point load is 45. This load is 20 kilonewton. This is also 45 kilonewton. This load is RD. This is RB. This is CE. Now, how we will convert UVL to point load? We will draw the UVL. This distance is given as 4 meter. So this is 12 kilonewton per meter. UVL is half into BH, area of triangle formula. What is B value? B is this. H is, this is H. So half into 4 into 12. So 1 2s are 2, 2 2s are 4. So 24 kilonewton. You see here, this is 90 degree, right angle is here. From here to here only we will calculate distance. This distance is B by 3. What is B value here? B is 4. 4 divided by 3 equal to 1.33. So this distance is 1.33. So what is this distance? This distance is 2.67. The whole is 4 meter. This distance is 2 meter. This distance is 2 meter. This distance is 3 meter. This is the free body diagram. Free body diagram finished. Next, we will find RB and RD value. Next, to find RB and RD value. First, we will take summation of f of x equal to 0. Draw the graph. This is x-axis, this is y-axis. Y-axis is in vertical, x-axis is in horizontal. You see in this FBD drawing, any force is in horizontal direction? No, all is in vertical. So, no force is in horizontal direction. So, neglect summation of f of x. So, this is no need. Next, we will take summation of f of y is equal to 0. You see this graph, y is in vertical. So vertical arrow goes upward, we will take it as positive. You see the arrow comes downward. Upward only positive. Downward is negative. Negative 45. Next you see upward. Upward is positive. Plus RB. Next is comes down. Down is negative. Negative 20. You see this arrow goes up. Up is positive. Plus RD. Next. Here is one force comes. This force is 24 kilonewton. You see here UVL force is 24 kilonewton. This force also comes down. Down is negative minus 24 equal to 0. Add this 345 plus 20 plus 24 is minus 89 plus RB plus RD is equal to 0. RB plus RD is equal to 89. Next, we will find summation of MB is equal to 0. Clockwise is positive. Next, summation of moment B. You see the force B. Before that, one force is there. That force is act downwards. From here to here, you see anti-clockwise. Anti-clockwise is negative. Minus 45 into perpendicular distance from here to here. Distance is 1.5. We will take 1.5. What is moment formula? Moment is force into perpendicular distance. Next, we will take B. Moment B is equal to 0. We will take this force. This is also 0. If you have applied moment in the point B, that force should be 0. Why 0? The distance of point B is 0. You see, no distance, right? So distance of point B is 0 and the moment also 0. So we will take RB into 0. Distance is 0. See, this is A. Now we will take this force from here to here. You see, this is clockwise. You see, clockwise is positive. Plus 20 into, what is perpendicular distance? So perpendicular distance is, you see, 2. Next force is goes up. So up is from here to here, you see, up to B. This is anti-clockwise. Anti-clockwise is minus. So RD into 4. Minus RD into 4. Next, you see this force, arrow comes down from here to here, you see clockwise. Clockwise is plus. Plus 24 into, what is the perpendicular distance from here to here? 2 plus 2, 4. This is 1.33. So 5.333. Minus 45 into 1.5 is minus 67.5 plus 0 plus 40 minus 4 RD plus 24 into 5.33 is 128 equal to 0. 4 RD is equal to 100.5. RD is equal to 25.125 kilonewton. What is RB value? RB is equal to 89 minus 25.125. RB is equal to 63.875 kilonewton. So this value is 63.875. This RD is 25.125. I'll write it here. RB is equal to 63.875. RD is equal to 25.125 kilonewton. You see here, first one FBD finish, second one RB and RD calculator. Third one, we will calculate shear force. Shear force calculation. What is shear force? Algebraic sum of the vertical forces acting on the left or right of the cut section along the span of the beam. We will see two rules of shear force. It goes up is positive. It comes down is positive. This is positive shear force. This is left side. This is right side. Next rule is negative shear force. It comes down is negative. It goes up is negative. This is left side. This is right side. This is second rule. This is first rule. Now we will calculate shear force at A. First we will take left side. You see the shear force at A, no force is there. This is 0. Now we will calculate right side. This is the right side. Or you see this FBD drawing, arrow comes down. Right side down is, you see, positive. Plus 45. Next, you see this arrow goes up. Up is negative. You see the right side only. This is right side, this is right side. This goes up is negative. Minus 63.875. Next, you see this arrow comes down. Down is positive. Plus 20. Next, you see this arrow goes up. Up is, you see, negative. Minus 25.125. Next, you see this arrow comes down. Down is positive. Plus 24. Add these three. 45 plus 20 plus 24 is 89. Plus, so add this to 63.875 plus 25.125 is minus 89 equal to 0. You see the shear force at A, left side and right side answer is same only. Next, shear force at B. In this we will calculate left and right side. This is A. Here is point load. Here is RB. This is 45. First we will take left. B left is up to here is left. Right means up to here we will take it as right. From here to here. This is right side. This is left side. First we will calculate left side. Left side you see from here to here. Left side is up to here only. I will draw and show you here. Up to here is the left side. Up to here. This side. Right is up to here. This is the RB. So right side from here to here we will calculate. We will calculate left side from up to here. You see the force comes down. Down left side is, you see, minus 45. You see any other force is there? Nothing, right? So 45 kilonewton left side. Next, right side up to here. I'll show you up to here is right side. You see here arrow comes down. So down is, you see, negative. Minus 45. Next, you see this arrow goes up. Up is, you see, positive. Plus 63.875 equal to plus 18.875 kilonewton. Next, we will calculate shear force at C, left side. You see here, Shear force at C, left side. Shear force at C, left side means up to this point. You see this arrow comes down. Down left is minus 45. Next, you see this force goes up. Up is positive plus 63.875. We are calculating up to this. Minus 45 plus 63.875 is plus 18.875 kilonewton. Next, we will calculate right side. Shear force at C right side is up to here. From here to here, we will calculate. Up to here is the right side. You see the arrow comes down. The arrow comes down left side is negative 45. Next, the arrow goes up. Up left side is positive plus 63.875. Next, arrow comes down. Down left side is, you see, minus 20 equal to minus 1.125 kilonewton. Next, shear force at D. Now calculate shear force at D, this point. Left side is up to here. This is D up to here. From here to here we will calculate. You see the arrow comes down. Down left side is negative, minus 45. Next you see the arrow goes up. Up left side is positive, plus 63.875. Next you see the arrow comes down. Down left side is negative, minus 20. Next you see up to here, right? So only 3 forces is there. Minus 45 plus 63.875 minus 20 is equal to minus 1.125 kilonewton. Next is right side. Shear force at the right side is up to here. I'll draw and show you here. Up to here we will calculate. You see from here to here we will calculate. This is and all left side. You see the arrow comes down. Down is, you see, minus 45. Next you see the arrow goes up. Up is positive, plus 63.875. Next you see the arrow comes down. Down is negative, minus 20. Next you see the arrow goes up. Up is positive, plus 25.125 equal to 24 kilonewton. Next, we will calculate shear force at E. So this E point we need to calculate. So shear force at A and E is always 0 only, equal to 0. Shear force at A is equal to 0. Shear force at B, left side is minus 45 kilonewton. Right side is 18.875 kilonewton. Next, shear force at C, left side is 18.875 kilonewton. Right side is minus 1.125 kilonewton. Shear force at D, left side is minus 1.125 kilonewton. Right side is 24 kilonewton. Shear force at E is equal to 0. Next we will draw shear force drawing. That is A, B, C, D, E. Shear force at A is 0. So point is here is 0. Next, shear force at B is equal to minus 45. So minus 45 is comes down. 45. You see the drawing, AB is in UDL. So UDL means how you will draw, this is in inclined line. Next, shear force at BR. This is BL. BR is 18.875, that is plus. So plus 18.875 is here. So this is 18.875. This is BR. So draw the line from here to here. Next, shear force at C, left side is 18.875. So this is also 18.875. Join the line, straight line. Why we are drawing straight line? This is point load. Next, this is CL. What is C or right side? Minus 1.125. So minus 1.125 comes this side. So 1.125. Draw the line down. Next, DL. DL is also minus 1.125. Here is also 1.125. Join the line. Next, shear force at DR. R is 24 kilonewton. So 24 is comes here. 24. Draw the line. This is also straight line. This is DR. This is DL. Next, shear force at E is equal to 0. 0 is here. You see this is UVL. UVL is in parabolic curve. So we will draw parabolic curve. This is parabola. This is negative. This is positive. This is positive. This is negative. This is shear force drawing. You see here up to shear force calculation and shear force drawing finish. Next we will calculate bending moment calculation. Bending moment calculation. Bending moment at A. Bending moment A is always 0 and E bending moment also 0. If you have applied moment at point A, that force should be 0. The distance of the point A is 0 and the moment also 0. You see no distance is there, right? So this is 0. Distance is 0. So A into 0, 0. The same way, bending moment at E is equal to 0. If you have applied moment in the point E, that force should be 0. You see here no distance is there. So E into 0 is equal to 0. Next, bending moment at E is equal to 0. Bending moment has two rules is there. First rule is the arrow goes clockwise is positive, arrow goes anti-clockwise is positive. This is left side, this is right side. This is positive bending moment. Second rule. It goes anti-clockwise is negative, clockwise is negative. This is left side, this is right side. This is negative bending moment. Second rule. Next we will take bending moment at B. Bending moment at B. You see this force. Before that one force is there. You see it goes anti-clockwise. This is left side. Left side anti-clockwise is minus 45 into, what is the bending moment formula? Force into perpendicular distance. What is the perpendicular distance is 1.5 equal to minus 67.5 kilonewton meter. Next, bending moment at C. C is here. From here to here we will calculate. You see this force, arrow comes down from here to here, you see anti-clockwise. So anti-clockwise is negative for left side, negative 45 into, what is the perpendicular distance from here to here? So from here to here is 1.5, here is 2, so 3.5. Next, you see this arrow from here to here. So the arrow goes clockwise. You see clockwise. Clockwise is positive, plus 63.875 into, what is the perpendicular distance from here to here? 2 into 2. Minus 45 into 3.5 is minus 157.5, plus 63.875 into 2 is 127.75, equal to minus 29.75 kilonewton meter. Next, bending moment at D. Bending moment at D. D force is here. From here to here calculate. You see this force is anti-clockwise. So anti-clockwise is negative. Minus 45 into, what is the perpendicular distance from here to here? This is 4. Here is 1.5. So 5.5. 5.5. Next, you see this arrow from here to here. It goes clockwise. Clockwise is positive. Plus 63.875 into perpendicular distance from here to here, 4. Next, you see this force, arrow comes down from here to here. From here to here is anti-clockwise. Anti-clockwise is negative 20 into perpendicular distance is from here to here is 2. Minus 45 into 5.5 is minus 247.5, plus 63.875 into 4 is 25.5, minus 20 into 2 is 40, equal to minus 32 kilonewton meter. This is under all left side calculations. Left side only we calculate. Right side also you can calculate. The same answer only comes for this. Now we will draw bending moment drawing. You see bending moment at A is equal to 0, E is equal to 0. Now we will take this A point is 0, E point also 0. This is D, C, B. Next, bending moment at B is minus 67.5. We will take here 67.5. Next, bending moment at C is minus 29.75. Minus 29.75 is here. 29.75. Next, bending moment D is minus 32. Minus 32, we will take it as here. 32. Now we will join the line. You see this drawing, AB is in UDL. So UDL is in parabolic. So we will draw, this is parabolic curve. Next is in point load. Point load is in inclined line. Join this. Next is also point load. You can join. Next, you see this is UVL. UVL is in cubic curve. Cubic curve means you can draw this way. Cubic curve. This is cubic. This is bending moment drawing. So this all is negative. Thanks for watching this video.